Hello, I'm Sean Godden, and in this video I'm going to explain how I constructed this GeoGebra sketch for my alternate angles column slicing squares from January 2022. So in this sketch, it's basically a show of the Pythagorean Theorem. In it, we've got our two squares on one side of a right triangle. One of the squares is being cut into four pieces by two slices. We can change the locations of those slices by using these points here. We can also change the size of the second square with this. When we get things as we want, we can press animate, and it shows how the larger square on the hypotenuse is equal in area to the other two squares put together. Okay, so to take a peek at this, we'll look at the algebra mode. I'm just going to pause for a second and hide everything so we can kind of go from the start. Okay, I guess I can't hide the buttons easily, but just to give you an idea of how I started, I created the big square. I did this by basically typing these coordinates in, and if you look at the statement a equals 0, 0, that's how I typed it in. I created the points for a, b, c, d, joined them up to make our original square. Once I did that, then using the reflect about a line, I reflected point A about BC to get this point A prime. And the reason for that is I wanted my second square to be not as smaller or equal to this square here. This guy was going to be static. The other one I could change the size. And since I'm setting up the sides of my right angle triangle, I'm basically setting up a line segment here where I would construct a point on that line segment using our point on object up here. And this is going to be one of the corners of the other square. After I did that, then I could just hide these two things and go through, and I constructed the smaller square by doing some perpendicular lines to this through those 2 points. And then there's lots of ways we could do circles, the square. I basically did a circle centered on one of the points through the other, and then the same thing over here, and then those give us the two corners of our square. And then I can go and hide all this other stuff and construct my sides, or draw my sides of my square. And now I've got my other square. What's this guy? Then there's my hypotenuse. And then what I did was, because I know that I'm going to construct a square on here, I kind of need those corner points to anchor my pieces that'll go later on. So to construct that square, I made a vector. Had to remind myself what I was doing. In order to get our slice in there, it has to sort of have the same slope as our hypotenuse here, or be perpendicular to it, which means that they're going to have a run of this big, which sort of shows us where our endpoints can be. So I cut off a segment here that was the same length as the side of the small square, so that I can put a point up here anywhere and the slope will reach the other side. Same thing over here. I put this point the same distance away as the length of the small square, so I can put a point on here to get my other little side. And then I constructed a segment here and a segment here that I can put my points that were going to be those control points for finding our slices. And then it's just a matter of, we know that the slice this way is going to be parallel to this line, the slice this way is going to be perpendicular to this line. I think I actually did the perpendicular one first using the perpendicular tool, and then I did this guy here is perpendicular to that, and then I can find these points of intersection to get the ends of my points and the point of intersection of the two things. And then I can actually go and hide these once I get those points, construct in my cuts, and find this point of intersection. That's going to be important so that I can construct my pieces, okay, using the polygon tool. So I'd go and construct my polygon. So there's one polygon, there's the other, the third and the fourth, and then I can construct the polygon for this guy down here. And then in order to have these things animate and go over, I created a series of sliders using the slider tool. Once I had the sliders, I went to its properties and set it up so that it goes from 0 to 1. I also did some scripting, which I'll get to later on. The idea for these things is what it's going to do is I'm going to translate these from here over to where they go later on. And so I'm just going to use this as a scale factor. I'll look at the vector that describes where this thing has to go. And then this will just be a scale factor that allow us to pull it along. Now, sort of an advanced thing that I do on this, and I sort of call them AS, BS, CS, DS, and SS for, there's my A, B, C, D. So I think of my square over here as being A, B, C, D. And so it's going to be, this is the slider that controls the piece that will go into the A position, the B, the C, and the D. And the S is for the small square. In the scripting, because these are going to be tied into my animate button, so for the scripting, I've put a little thing in here that basically says, and this is a nice feature of GeoGebra where you can add these scripting things to some of your items, so that if you do certain things, you can sort of write a little program that listens to that. So what I've done is I put this start animation BS kind of AS equals 1. So what it's saying is if this thing gets to 1, then what I should do is start animating this guy, okay, and make it move. And similarly on this one, when I put one that when this gets to 1, it should make this one move. When this one gets to 1, it should make this one move, and so on. So that what will happen is the pieces will slide over one at a time. Once one is there, the other one will start. When one is there, the other one will start, and so on down the line. So that if I actually look at the properties of my animation button, we see on click, the first thing I do is I set all those factors to 0, and then I animate the first one. And because I set it up so that once I get it done, like you'll even see if I just pull this over to here, as soon as I get to 1, my animation follows through. And then with my reset button, I just set that thing up so that pressing reset just resets everything back to 0. So clicking reset sets those guys back to 0. So if I Quick reset, they're all back to 0. From there, I constructed the points of my square by just rotating. I rotated this point around here 90 degrees, and then I rotated this point around here 90 degrees to get my 4 corners of this square. Again, lots of different ways you could do it. Once I did that, I set up my vectors. So this A new, if I think of my, I thought of my square as A, B, C, D, so my new square is going to be like A, B, C, D. So I'm thinking of this bottom left corner as A. So if I look at my pieces, this piece has the bottom left corner. So that piece has to go to A, so that's the vector that describes how this piece has to move. That's the vector that describes, B new, same idea, how this piece, the bottom right corner, similarly C new and D new. And then I had a little bit of a problem because for my first sketch, I did some computations with these vectors. I just multiplied them by the scale factor and it gave me a vector and everything was happy. And then this time, when I did that, when I went to do AS times A new to give me the vector, because again, this would just give me the factor that I've moved along here. It actually gave me a point for some reason. So when I did this, if I go to the properties of this AM, what I had done is taken that factor and multiplied it by the vector, and that was going to be the vector that describes how this thing moves. Unfortunately, it didn't give me that, so I had to then create another vector that basically says the vector that goes from 0, 0 to this point. And you'll notice if I move this along, a little bit, there's my A move is this point, and then it gives me that vector. And the same thing with the other guys. And I guess I can hide all these things now. I can hide these vectors. Okay, so that describes how those things are. And then from there, I could create where are these things? Oh, they're there. Okay, so there's the image of this guy as it moves along. And then same sort of thing. Then I could, using the translate by a vector here, pick this guy, pick that vector A move, and that's how it's going to be. But now that vector is dynamic depending on this thing. And once it slides into place, again, we've got one that does the B, the C, the D, and we can get all of those pieces. There's B. C is probably here. There. Let's say there's C. D would probably be this guy. I didn't go and rename these guys, so can't see that. And then for this one, after I sort of put all those guys in place, I had to figure out where this is going to be. And so I created a vector that moved this from here to here, and just sort of looking at these pieces. I forget how I did it. It was probably this guy here. So this point here is actually right here. And so I probably said, okay, whatever this guy had to move over there, this guy's moving the same, but then move it back so it fills up this hole. So I came up with a vector for that guy, and then same deal, created that, and that's that. And so once we've got all of those things in play, I can hide all the stuff that I don't need, all of our sliders, We don't need all of the, oops. And then there we go from there. Now I'd also go and hide all the points and just keep the control points on there. So, hope that helps.